Hello and welcome to this first video on DSL3S. DSL3S is the acronym for Domain Specific Language for Spatial Simulation Scenarios. It is essentially a project to apply the model-driven development philosophy to the field of spatial simulation. In this first video I will provide a general overview of the project, DSL3S language and its main goals. First of all, I would like to start with a quick glimpse on what is spatial simulation. This is a Java applet implementing an old model that dates back to the 1980s. There are two species spread across space, and with very simple rules it is possible to observe population dynamics features that are also observable in natural environments. This sort of models became more and more popular, especially after the emergence of object-oriented languages in the 1990s, to study how spatial features evolve with time. A host of tools and libraries emerged that are used in a broad range of applications. But these tools remain mostly accessible to users with strong programming skills. Hence the need for projects like DSL3S that try to bring closer spatial simulation to non-programmers, to GIS experts, to researchers that may not have the required programming skills. So what is model-driven development? Basically, it's a methodology that tries to put modeling at the core of the software development process, and tries to achieve this by raising the level of abstraction at which software developers work. Here, this picture that's taken from a classical article by Atkinson and Kuhn, we have a visual metaphor for this. Collie traditionally would be modeled as a class or maybe as a table in a database, but with model-driven development it's actually modeled as a breed, because that's what it is. It is a breed of dogs. To work like this, model-driven development requires the creation or the identification of a meta model where ontological concepts are gathered. This way, software developers worked in a restricted domain where they used concepts that are only relevant for the project at cause. And what are the advantages of using model-driven development? Here at the DSL3S Wiki, a few of these advantages are listed. First of all, the gathering of domain-specific concepts in a meta-model produces a language, a domain-specific language, that by itself makes models, the products of software development, much easier to understand because they are graphical constructs. Secondly, models can be validated at a much higher level of abstraction before any code has been generated. Thus, prototyping requires much less effort. Then, as code is generated from models, there is an advantage regarding interoperability, because from the same model, code for different platforms can be easily generated with the appropriate templates or model to code generation transformations. Secondly, as the code is being generated automatically, the code quality can be uniform. It can be And to finish this video, just a quick rundown of the meta model of DSL3S, basically the concepts that have been captured that try to represent the domain of spatial simulation. First of all, there is the concept of simulation, which basically gathers several elements that together can create a simulation. In a spatial simulation there are two essential kinds of variables. First of all, spatial variables. These are traditional spatial layers that are fed into a model and that provide assets and background information to the actors of change. And then global variables that do not exist at a specific point in space but still provide important information to the actors of change. Actors of change in DSL3S are called animats. This is a term that was coined in the early 1990s. Hasn't been used that much, but it's an interesting metaphor and allows us to abstract from certain technical implementation aspects. Basically, animats are the actors of change, are those elements in a simulation that change variables around them, that may change other animats. For instance, a good example are the predators and prey from the model that we saw in the first part of this video. An animat is in itself composed by a series of attributes that describe the internal state of an animat at a certain moment in time. And then finally, an animat can have a series of operations that allows it to interact with other animats in the first place, to interact with variables, and actually to have a life cycle. At this stage in DSL3S there are 6 operations available for animats. Emerge, which sets how an animat may appear in a simulation. Move, that defines how an animat moves across the space of simulation. Supply, whereby an animat advertises a resource that it makes available to other animats. Harvest, which is an operation by which an animat can take resources from another animat or information from another animat, or take information from spatial variables. Then there is the replicate operation that defines how an animat may replicate, for instance as in a predator-prey model. And finally perish, that sets how the life of an animat comes to an end. So these are the main elements of DSL3S. It is at this moment a relatively tight language, but it already allows the creation of very different models with different applications. So this is the end of this video. In the following videos I will show how to install DSL3S and how to use it and create models with it. Thank you, and see you another time.